Hi everyone, and welcome to another episode of the Bugging Maths. In this video we'll discuss the position or the coordination of a matrix. So let's get started. So before you start panicking about this equation, don't worry, I'll explain everything to you. It's very simple and it all makes sense. I'll explain it to you. So we need to understand the position of a matrix first before looking at minors and cofactor, or how to find the determinants using minors and cofactor, because these symbols will be very important. So you need to understand what these symbols mean and how to place them. It's very simple. It's just like labeling, but you can't go all the way to cofactor and minor without understanding the position of a matrix first. So very quickly, let's look at what the position of the matrix look like. So like I said, the position of the matrix, that is the coordinate. So this is a 2 by 2 matrix, like we know. Okay, so now what is the position of this matrix? Like, this is 2, we have 2 and 2, but which 2 am I referring to, right? Which elements am I referring to? That's why the position or the coordination of a matrix is very important. It's like us labeling the matrix specifically, that okay, this is the one I'm referring to, this is the one I'm referring to specifically. You get it, right? You need to get that fact first. It's like us assigning and saying that this is the element of this matrix that I am looking for exactly, or that I'm referring to. These two here will be called A, like this is matrix A, so small letter A 1 1. Do you know why? Because this is the first row and the first column. So that's how we read their coordinates. So we're referring to A 1 1, which is 2, not this 2. This 2 will be where A 2, A2, because this is second row. A2 what? First column. A2 1. You can see that these two, they are different, so we need to assign them correctly. How about this matrix here? This one will be B, right? B what? 1, first is on the first row and the second column, so B 1 2, second column, that's equal to 3. What about 4? 4 will be B2, because it's in second row and second column, 2 2. So that will be 4. Okay, what about this 3 by 3 matrix? So if you want to read the position, obviously you start like this: A, B, and C, right? That's the first thing to do. To know that this is capital, small letter. You can name it anyhow you want, but your textbook will usually use A, B, and C. But you can call it any alphabet you want, but based on we are using small letter A, B, and C, let's use A, B, and C. So A, B, and C. So this is the first column for A, second column for B, and third column for C. So why A will be A what? A1 2. Like I said, it can be represented anyhow. You can, but what we're referring to is the coordinate. This is the most important thing. But here now they are using A for every single thing, but I use A, B, and C, right? So now they are saying A for every single thing. They don't care about A, B, and C. So don't let that confuse you. So this one now they are saying what? A1 2. That's what? First row and second column. So that's, they are referring to these two here. So for them, their own A1 2 is 2. But for me, I use B. So let's just change it and use A for everything. A, and A. Doesn't really matter. This is A1, this is A2, and this is A3, right? So what about this one? Where is A1 3? That will be A first row, right? First row and the third column. First row and the third column. That is A1 3, first row and the third column, which is 3, the element 3. So you can represent it anyhow, like A, B, and C, X, Y, Z. It doesn't really matter. What is important is the base, the superscript here: 2 1, 2 1, 3 2. But first of all, we are dealing with the small letters. Small letters represent the position of each element. Don't worry about this one now. Don't worry about the capital letters first. We'll talk about that later. It's also the same thing, very, very simple, even more simpler than detecting where the position of the coordinates are. So now, if you look carefully, now they are using A instead of A, B, and C. So they can represent it anyhow, as long as the position, we don't care about the alphabet exactly. All we care about is the position of the matrix or the coordinates of the matrix. So where is A21? A21 will be where A, right? A, and then 2. That is where the second row, 1 and 2, and 1 will be the first column. So we read it column, number of columns first, and then number of rows second. So A2 will be second column, but what element in second column? The first. So first column. What element in the so this is what they are looking for here. 2, 1. So that is equal to 2. Let's try another one. What about A32? A32. That would be A, the third row, right? 1, 2, 3, right? And the second column. So 1, 2, 3, and how many column? 1, 2. So they are referring to this guy exactly. So this 2 here, which is equal to 2. So you can see you have 2 of them too, but which 2 are referring to? You can see the, I'm sure by now you can appreciate the coordination of the position. It's very, very simple, and it's all we're doing basically is just representing them by their position. So I'm sure by now you understand what the position, the small letters, the position are. If you still don't understand, make sure you go back and watch the video again and again and you get it. So this is this and this is that. But what about this? This is the minor now. We're not talking about this now, but let me just briefly introduce it to you. Every element, every position, every element, what about this is A21, right? That will be second row and first column, which is they're referring to these 3 here. So every element has what is called a minor attached to it. So these 3 now, we have a minor attached to it. It will have a minor attached. Don't worry, in minor and cofactors, I will explain what these things mean and how we can use them to find the determinants of a matrix and what exactly determinants are and why do we even use them.